haven't got a hub yet, so you have to do it manually.
Okay, sure.
In which case, he won't have heard my audio test,
Okay,
but he will now hear it.
but he will call you if he doesn't get it.
I'm sure he will call me if there's a problem.
Yeah.
We have 40 seconds. Yeah, that should be fine. Good, good. Well, I can go up to my office and I can log into the stream. So I can go and do that now. Meanwhile, if he phones me, meanwhile, if he phones me, I can run down in a panic.
Okay.
Okay.
Okay, fine. Students, welcome to overview of natural language processing / natural language processing. It's actually 3 courses in one, and there was a bit of commotion here because we're also live streaming to engineering, who are also taking this course. My name is Simone Teufel. Just to remind you of a few ground rules because we're starting the course. Don't bring anything but water in here. You're not allowed to take any recordings, audio or video, of lecturers while it's going on. And if you come after 10:05, please remember to take the upstairs door. Come from the first floor. Right, okay. So today is the overview lecture. I'm going to tell you what the course is about. And one of the first questions that come up is, if language is so easy in my own head, why is natural language processing hard at all? And I think it requires some explanation. And then I'll show you the scope of natural language processing, which really consists of many subtasks. So we'll go through some of the applications and subtasks. And then there's a sample application, sentiment classification. This is going to be of interest to all of you who will be taking one of the 2 practicals associated with this, because you'll be building a sentiment classification system, or if you're part 2 and you've done MLRD, you'll be beefing it up seriously. And I'll step through the subtasks of what needs to be done in a natural language processing system, which also leads to a map of how the other 11 lectures are organized. So here, this is about assessment and how we're trying to do 2 different part 2 and ACS in one course. So all of you will listen to the same 12 lectures. But on Wednesday afternoons, and this will all be announced, there will be 3 practicals for each of you. So let's first look at the part 2 practical. This is people who have, about 1.5 years ago, gone through machine learning and real-world data. So there will be a similar practical that's about half of your assessment that will be using Doc2Vec, a deep learning architecture, and measuring the improvements on your system. They should be quite large. And in the second part, you will be doing something that is much deeper and that can't currently be done end-to-end with a neural network, and that is a text understanding. QA stands for question answering task. You'll be simulating to be a second language learner of English and simulating the tests that they go through, the questions they go through, whereby the assessors check how deeply you've understood the text. In ACS L90, so this is a different set of people. If you're ACS L90, you should see this in the framework of other MPhil courses that also deal with natural language processing. And for those, this is the intro course. This is the beginner course. So there's many more specialized modules. Your practical is going to be sentiment classification, but you'll be doing more. And engineering is also taking this course, and the practicals there are organized locally. Lecture notes come in batches, and I apologize that today you don't have any yet. I will put them on the web just after this. There's a little chapter for each of the lectures, but none for the last lecture, because that's something that we change yearly. And to be honest, I haven't yet decided which new development I'm going to present in that. This lecture course will be delivered by mainly 2 people, and then Anne Kopsteek, head of department, who's actually created this material, is going to give 3 lectures to you as well. The slides are supplementary, so to learn this well, we really recommend that you look at the book. So the book is Jurafsky and Martin. We're mentioning here, this 2008 edition is the 2nd edition, but what's great about this book, there's many things that are great about this book. It covers everything, and it is mathematically very correct and quite deep, and really huge coverage. But it also has a online version for free of most of the chapters as they're being updated. So this is the current 3rd edition. So just Google that and you'll get but it doesn't have all the chapters yet. You should go back to the 2008 background. So there's the book, there's the lecture notes, and there's the slides. And there might be slight variations in those, but I think in terms of linguistics, we're going to be trying to deliver this, not artificially putting any technical terminology, linguistic terminology in there that you don't need, but you will be needing quite a lot of linguistic technology. I hope to define them as I go along, but if you're, if there's something you don't understand, I'd be really thankful if you ask the question. If there's something you only notice later you don't understand, please go to the glossary. Glossary is explanation of technical terms that are in the lecture notes. And or, this is my recommendation, if you're maybe a bit more interested in linguistics, read the book by Emily Bender. That's also got a link on the website. And this is an excellent, very short explanation of which part of linguistics are relevant to computer scientists or to computational linguists. Very well written. And we will also put links to running software, to demo, similar things that fits to each lecture. So we don't say this explicitly and you don't have supervisions, but it could be fun and good for you to try some of the things that we discuss here theoretically, try them out with your own hands. So here is what will happen in the course. The next lecture is concerned with how words are structured internally. And what's running through the entire course is that we need to model meaning. So already when I talk about how words are put together, I'm talking about meaning units. So which parts of the word are, say, the word stem, and they need to go in the lexicon, and which of the words contribute some other kind of meaning. For example, if this is a verb, it tells you that this is the past tense, and so on. English is one of the morphologically poorest languages in the world. There are many, many other constructions that are nonlinear, for example, for Semitic languages and so on. So you get an insight into those, and also how they're modeled. Syntax is the way how words are used, how phrases are formed from words. So the lowest level of syntax is part of speech determination. For each word, tell me its syntactic function within the sentence. And then we'll be looking at phrase structure parsing and also dependency parsing. And you'll, in particular, for those of you who have taken formal models of language, you will see clear parallels of how, in that course, Paula Buttery was contrasting natural language syntax and compilers, artificially built languages. And the key difference that we as linguists have to deal with is ambiguity. So a lot of these lectures will be dealing with how to computationally cut down and keep a handle on ambiguity. Semantics is the study of meaning. And there's many different ways to look at meaning. The traditional way is to consider semantics as a symbolic language that you puzzle together from the output of your parser. So depending on the syntax, for example, if you detect a passive with your syntax because of the order of the words and the kind of endings in the morphology, you will build a representation of what that sentence means that can be mapped onto an active sentence. So the same agents, or in the case of a passive, maybe missing agents, will be projected onto the same part of the semantics, and much more complicated. But what we take away from compositional semantics is something that is a representation that could, for example, be a first-order predicate logic, or it could be a lambda calculus, or those kind of representations. This is kind of, I don't want to say the old style of semantics, but this is symbolic semantics. And recently, other aspects of semantics have been studied a lot more. One of these is lexical semantics. Which properties concerning meaning do words have that are directly located in the words themselves? So lexical semantics is, for example, dealing with the types of relationships that a word has with its hyponyms, its supertypes, or its hypernyms, its subtypes, or the tendency of two words to go together as a compound noun according to different semantics. So this could be the difference between a wood screw and a wood screw is a screw that screws into wood, like sticks into wood, whereas a brass screw is a screw that is made of brass. And you need a lot of world knowledge in this particular example to distinguish the two, even though on the surface, both wood and brass are materials. So you need to know a lot more about what a screw does, the function, and so on. So all of these could be aspects of lexical semantics, and also just the determination of different word senses is part of lexical semantics. And then you'll be looking at distributional semantics in vector spaces. This is a relatively old and then gone out of fashion and then recently become very popular idea that we don't need to bother with all that symbolic stuff, writing down complex first-order predicate logics or studying exactly what the relationship between two words are, because all we need to do is represent a word by its neighbors. And there's various ways of doing that. And the general idea of distributional semantics is that of high-dimensional semantic spaces. So words are situated somewhere in this high-dimensional space, and we can measure how close they are. And the dimensions are determined either by other words, these are the simpler semantic spaces, or they're determined by something else that your neural network has decided is the dimension and has trained while it's doing. So there's one lecture reserved to word embeddings and deep learning approaches to semantic representation, whereas the first one is a general introduction to semantic spaces. And in a way, people often think of computational linguistics as a layered thing. So, you know, the different types of analysis in their order of abstraction being put on top of each other. We're now going towards the top. So there's discourse structure and pragmatics. This is the interpretation of what a sentence means that depends on which sentence or utterance came before and what comes after. One of the examples that we'll be looking at here is how does a pronoun in a sentence change according to what happens before it? And how do I interpret what that pronoun refers to? Then, and this is typical for other NLP courses as well, most of what we talked about is analysis. The assumption is you input a natural language string, either in text or by a spoken by a speech detection system, and then you analyze the meaning, and then on the basis of you having understood what is meant, do something on that side, like an agent. But of course, the output side is language generation. Say we already know what we want to say, how do we say it? Or if you have a dialogue system, you will have to go from spoken input to whatever level of understanding you have, whatever information access you have, and then back out So lecture 11 is going to look at language generation and language regeneration. And then in lecture 12, I will probably do textual entailment, because that also has something to do with your practical. But I haven't decided yet. So I'll make an example, and this is an example roughly based on a real company that, startup company that was successful for about 5 years, and that was dealing with pre-processing of user email to companies. So the scenario is they were promising to route 90% of the emails to the right person without having to go through an operator. And this is a theme you will see through lots of NLP. Nothing in NLP is ever 100%. It is so complicated. Like dealing with language and dealing with meaning is so complicated that approaches that give us 80%, 90% are often enough. So 90% was like a really exciting sales pitch. And the idea was, impatient user asks, has my order number 4291 been shipped yet? And that is a very well-formed sentence. I can see the auxiliary starting it. I know that it's a yes-no question. I can see that the surface subject, my order number 4291, is actually in a passive construction, and that means somebody else shipped that order. And you know, I need to, they may have said sent, or they may have said shipped, but it's still pretty clear what's happening. So let's say I understand the meaning of the word ship as in sent by mail. A database that gets the information that, okay, I only need one bit of information here, yes or no. And the user has been so nice, given me the exact number and told me that it's an order number. In that scenario, after syntactic analysis, the system would generate the DB query. So this is now the agent sitting at the other end doing something with the information that was transmitted through the code of natural language. And the response in this case is, because date shipped has been filled, I can send the bit yes. But the response is actually much more cooperative. This is where pragmatics comes in. So what would a human do if they were asked, has my order number been shipped yet? Yes is enough as a minimal answer, but a user would know that, an operator would know that a person impatient enough to ask that, or a person with that question, would additionally like to have the answer, when was it shipped? Okay, so all of that can be hard-coded, say, in this particular system. So, okay, so now you say, easy peasy, right? Why this is difficult is because this is, okay, ambiguity, people will give you the same explanation all the time. Similar strings mean different things, and different strings mean the same thing. So in this scenario, this is a phone hardware company, say. So they're asking, how fast is the T-SED? And that is quite similar to that user actually asking, how fast will my T-SED arrive? The first one is asking for a property of whatever that T-SED is, whereas the second one, it also has the word fast in it, and it's even pre-modified by how, the WH phrase, same way, but it's really asking about, so this is an adverbial situation, and it's asking about the arrival of the T-SED. So now what the system needs is actually knowing that something that was shipped will arrive afterwards. And what the user is asking is not the shipping date, but shipping date plus however long, you know, that thing is going to be in the mail. And very crucially, on the surface, it's a very different thing. In order to answer the question, how fast is the T-SED, I need to understand that this is looking up. This is a lookup in the specifications database. And this is, again, the question about the shipping, but just said in a more polite way. Please tell me when I can expect the T-SED I ordered. And please notice there's almost no word that is shared between 2 and 3. So this is what always happens. If you could train your users to just talk in order numbers and in arriving and in shipping, everything would be fine. But damn, those humans, they just use the code of language any which way they learned it. And they use it every day. And that's our difficulty. The range of variation is very big. And the context and our ability to adequately model the context is not that great yet. So, for example, they may have mentioned something they're expecting and then go off on a tangent and talk about God knows what in that email, and afterwards they might just say, and when will it arrive? I've waited forever. And for a human, it's clear that thing can only be, because that's the purpose of the email. But for a system to actually understand each sentence, this is very hard. And then there's forms of ambiguity that are actually very, very string-based and very obvious. So this is a famous ambiguity in natural language. And so the user might ask, do you sell Sony laptops and disk drives? And there's a case in which this question can be answered without a question back. And that's the case when they sell Sony laptops and they sell Sony disk drives, and maybe they sell other stuff as well. Then you can just say yes and leave it up to them. But this thing really means two things. And there's nothing you can do except ask the reader. This ambiguity is inherent. You can't do anything about it. So they could mean, do you sell laptops and disk drives both by Sony? Or they could ask, I'm interested in Sony laptops and disk drives by whoever. So here is the logical thing that the agent should be doing. They should find out that there's two interpretations of that. They should check for each interpretation whether it holds. And if the truth conditions are not the same, it needs to ask a question back to the user. There's no other way around it. When you guys write your own text and there's an adjective or a pre-modifier that is modifying, so we call something a coordination if two noun phrases or two phrases are coordinated with each other. If you're doing that, and you know whether the adjective or the pre-modifier applies to both of the things that you're coordinating or to just one of them. If it applies only one of them, order the two things so that it would be saying, do you sell disk drives and Sony laptops? Right? This is the only way. This is the way that you at source can actually get rid of the ambiguity. Because in that case, the ambiguity is not really desired. But in many cases, and that's what I'm coming next to, is in many cases, ambiguity is actually, it's bothersome for us computation linguists, but it's actually a very attractive property of language. So, so many people, when I tell them up to here, they would go like, what bad cards we have been dealt by evolution and language development and being born into this language on this planet, into this language community, that we have to deal with ambiguity. It's so bad. Wouldn't it be better if we had a language that was actually logical? Wittgenstein, in his early days, tried to develop such a language in which there is actually no ambiguity. And you can construct it. It's kind of first order predicate logic. It's not complete, which we know since Gödel, but why aren't we? But still, it's a lot less bothersome than this. Why don't we talk in such a language? We could, for example, you know how in English we only have the pronoun he, she, or it. And if in the discourse you're talking about people and there's more than one female person, you still have to use she and somehow order it. Wouldn't it be nice if we just had variables, right? When Sabrina comes up, it's X1. And then Sandra comes up, she's X2, and then I just say X1, if I want to do it shorter. Like, why not like that, right? This is one of the first thoughts. And I can only give you a waffly answer to that, but human communication is, I could talk about poetry. I could talk about all the cases where ambiguity is actually desired. But it's not just in artistic situations where we like ambiguity. It's also Sometimes, for example, in English, you don't have to say whether a friend is male or female, and you can leave it hanging in the air, and that might, in some situations, be exactly the amount of information you want to give out, right? Ambiguity can work in our favor. And the language is extremely, another very interesting aspect is child language acquisition. We don't have time to go into this, but there's research in Cambridge going on about how children learn language. It's absolutely astonishing how fast a language of complexity of natural languages, and they roughly all have the same complexity, can be learned by a child. So that's what I mean by compact. It's learnable, it's compact. And then as the child grows, complexity grows along with understanding more of the world, which is amazing. Also, languages are evolving, emergent systems according to the social circles we hang out in and who we want to project we are. We can talk in different slangs, different subdisciplines. Many jokes develop over years. Metaphors develop. Someone says something clever and it strikes a note in people, and they just go around the world. And that can happen fast. So all of these are really attractive aspects of natural language. So, yeah, and then because that's how we communicate, and we like to communicate, and on the technical side, we just have to deal with the actual properties of real natural language. Nevertheless, with all this ambiguity, strangely enough, we can still make contracts, and we can still have meaning that is absolutely nailed down. And that is because we can be indefinitely precise in a language if we want. So first of all, you as humans very often do not perceive the ambiguity that is there. Your brain tells you right away which word sense is being meant. And when someone points out that could have been interpreted some other way, you're first surprised. That is because the brain does some amazing disambiguation very, very fast, within milliseconds. So the ambiguity is local, but so fast, usually in normal communication, resolved so fast that you don't even notice it. And then, for example, if you are a lawyer, the reason why legal language is that complicated is because we can add relative clauses, we can add technical terminology, we can add specific definitions, and we can hammer it down so that something stands up in front of a court of law if necessary. So there's a language called Lojban. It was developed from 1985 onwards. I didn't know the details of it. I went on Wikipedia yesterday and read about it. It's quite amazing. So person one says, if you learn to speak Lojban, your communication would be completely unambiguous and logical. And the other one says, yes, but it would be with the kind of people who want to learn Lojban. And may I add something to it? It's not just that the kind of people who feel attracted to learning Lojban are geeks or have something wrong with them. The language itself wouldn't allow you to do jokes and innuendos and things like that. NLP applications. On this slide are the simple ones. The ones that are bottom-up and that mainly deal with, say, characters or low-level things. So there's spelling corrections. There's spelling correction in context, which is what grammar checking is. Still not very good Grammarly and things like that, but more than we had 5 years ago. Predictive text is one of the simplest technologies, extremely useful, especially when trainable to a user. Optical character recognition is a technology that takes pixels on a screen and turns them into analog signals and turns them into actual characters. Here, there are lots of applications where linguistic plausibility is taken into account on, say, a letter that might be an it, might be an is, might be an if, and because these fulfill very different syntactic functions in the sentence, you could, you could use a statistical classifier to tell you how to correct that little smudge that's there. Screen readers are readers for blind and visually impaired people to not only read out text, but they could, it's part of augmentative and assisted communication, so they could have, for example, particular melodies for icons, or they could have something that outputs the information in a braille reader. There's, of course, machine translation, but here I've been careful and just written machine-aided translation. That's the difference between just how much meaning at the moment we can get out automatically. So people have been thinking much more instead of fully automatic. For something like Google Translate, it doesn't matter because it's an interactive thing. And Google Translate has gone a lot better, right? But for those high-quality translations where legal contracts or contracts between nations or, guess what the Brexit thinks, there will be lawyers, and this will be done exactly. The translation has to be exactly. And for those, even for those situations, NLP technology and machine-aided translation can help, but there will be a human in the loop in those cases. Lexicographers' tools. This is something that has come up in the 90s a lot when researchers in Birmingham had the amazing idea that up to then lexicons were constructed only based on the intuition of very, very knowledgeable lexicographers, people who go crazy over words and the exact meanings of words. And then in the 90s, we started to have support from large text corpora that give people not just frequencies of individual senses of words. They have to be manually annotated, these corpora. Some of them are done automatically, but also information about frequent collocations. Collocations are two or more words that occur together statistically more often than you would expect. So these are usually, they could be technical terms or they could be compound nouns that are very common. And these things a lexicographer normally knows, but, and this is another thing that is kind of a theme that goes through lots of what we do in NLP. Intuition is good, and linguists are trained to analyze sentences. They have tools, tests, that they try out different methods, and they can come up with very good analysis. And still, the most experienced people, when presented with some corpus evidence, especially from very large corpora, go like, oh yeah, that's the thing I would have forgotten. So even with the best introspection, nothing beats. So in data, there's always a big tail, a long tail of weirdness. And filtering the weirdness properly and presenting it to a lexicographer can really get better lexica, more realistic lexica. Then there's information retrieval. Yeah, we used to have a course here about that, but actually here we don't need to say much more about information retrieval than saying for NLP we often consider it as the first filtering step, usually done with semantic spaces or with vector space model or with even a Boolean model that pre-filters the documents so that more expensive NLP tools which are not as efficient can run on the more likely candidates for something. So when we're doing question answering, there's usually an information retrieval first step there. Document classification. Whenever you hear the word classification, you should ask by what principle. So usually when people say document classification, they mean by topic. So this could, for example, be a large news agency that is routing incoming ticker reports, routing them to the finance person or the sports person as they come in. But the kind of document classification that we'll be looking at is by sentiment. Document clustering is like document classification, but in clustering, of course, we do have the general topology and we also have distances between documents, whereas in classification, they just get put into a bucket. Information extraction is kind of also what the part 2 contingent of you will be doing in one of the practicals, namely extracting solutions, extracting answers to a question from a document. Sentiment classification. Text mining is usually the area of, in principle, text mining and information extraction could be the same thing, but generally when someone says text mining, they usually mean more robust techniques on much more data with less linguistic analysis behind it. These are the higher level NLP applications, such as question answering. Specifically, so the early question answering systems just gave you a snippet cut out from the text, but what more sophisticated question answerers are doing is only give the information that a human would be giving, which is usually cutting out a lot from the sentence or reformulating it. Summarization is, of course, the task of selecting information from a large sea, selecting the most important information, but recently people also look at the summary quality itself and, for example, the coherence of the text. And also, what is important in summarization depends a lot on the evaluation methodology. And more stringent evaluation methodologies, for example, look at how many sentences in that summary are potentially distorting the truth. We don't just count how many words you bring out that a reference summary also has, but the worst thing that a summary could be doing is making you believe something that is the opposite, and making you confident about that. So how often does that happen? These are much more expensive evaluations that happen. In the Computer Lab, we have a large research team run by Professor Ted Briscoe that is to do with language assessment and language assistance, like the two arms of second language learning exam boards. So automatic exam marking is one of them, and the other one is helping people, for example, customizing tools according to a second language learner's first language. If you're Russian, you might have particular problems with articles, but if you're Russian, you have no problems whatsoever with aspect of the verb, whereas if you're German like myself, and so on. So they find this out statistically and adapt their tools to it. Yeah, language teaching is the second one. Report generation is supposedly a form of summarization where, yeah, it's a form of summarization where the input is scientific articles. There's machine translation. There's natural language interfaces to databases. This was something that was extremely popular in the 80s and 90s, and that we don't hear about so much anymore. Email understanding, dialogue systems, so very important technology. So let's go a bit more into the sentiment and opinion mining area. What do people think about me? This is a multi-billion dollar industry. The task is to scan documents, for example, about politicians, about products that were recently released. Often these documents come from social media, and what companies are paying for is, big companies are paying for is often very quick responses in the social media to something that came out today, like a new iPhone that came out today. So this is done, I say multi-million, multi-billion, don't know, high value industry, often done manually, and recently in the last 5 years, many startups that do this automatically. So the general task is find all, so there's an entity. The entity might be a particular politician. So find all references to that entity, and it might not just be the name. It might be said in many other ways, like, you know, the latest newcomer in the Republican camp, or God knows what. There might be many ways of how that entity is referred to, and you want to classify them as positive or negatively, positively giving a magnitude to it, or neutral, and exactly as a human would be doing that. Like if I had to report to some manager about how something is working, I would probably say 75% positive, 25% negative, and then you want something like the most extreme positive or negative reviews, or even more sophisticated, you might want a summary of the most frequent negatively mentioned points and the most frequently positively mentioned points. So that would be text snippets, but you'd have to also select from the text snippet exactly which ones you think are most representative. And of course, it might be that in general, a particular product is good, but there's one particular aspect of it that's being picked on. Like, everything's good, but the screen's not bright. So this was a year ago's iPhone 8 review. Latest and best processor. Then talking about cores. Can use a combination of all 6 cores at once. Performance was excellent. No day-to-day speed compared to the iPhone 7. So we have a comparison there. What often happens in such reviews is that people talk a lot about the previous phone they had. And it's important for the natural language processor to actually find out which part of it they have to blank out. Yeah, you take into account that this is an iPhone 7 user, as opposed to someone who's never had a phone or comes from Android. But nevertheless, the information about the experience that was in the past, you need to detect that and kind of blank it out, because this is not a description of the new phone here, right? So actually, they say performance is excellent, but they don't mean performance is excellent because it's the same as they observed in their own phone, right? The only thing that is really positive here is the battery life. And hey, we're not talking a 2-day battery life here. Still not. The research task. Okay, the research task is a different task from the commercial task. If you're at a company solving this task, you do the information retrieval, you scrape the web, you know which social media you go to. You need to deal with things like HTML or whatever, XML data structure. You will perform the named entity recognition to find exactly that entity. You might do pronoun resolution to find even for matches. And then afterwards, you evaluate what your system outputs by humans. The research task that we'll expose you to, and sorry to the people from MLRD who know this pretty well, is a simplified, streamlined version whereby we have pre-classified documents. We have documents that also had a star rating. The topic is known. The topic is a particular movie, for example. And the opinion in the text is supposedly given as a gold standard, not by humans, but as a gold standard that comes together with the text. Corpora are important. So Pang et al. Have distributed a corpus of cleaned up movie reviews, and they've made it particularly simple by removing the neutral reviews. So we're just dealing with strongly positive and strongly negative reviews. This is a much, what I want to tell you is this is a much toned down version as opposed to the real task. But systems that perform well in this, we would expect to perform equally well in the wild. And it's a 50-50 split, so this is artificially biased so that we can easily run an evaluation on it. So let's look at a few movie reviews. This is a super rating, 9 out of 10. Ooh, scary. One of the most entertaining films of the early 80s. I think the moment the system were able to find that phrase, one of the most, and then afterwards, we might look for contradictions to that, except not, or something like this. But in this particular case, they say the most entertaining films. I might know, for example, from a lexicon that entertaining is good in the movie review world. Best work to date. There's only positive adjectives in there. The script is light and witty. Visuals are great, and so on. Top banana. So the standard technology is bag of words technique. We treat the reviews just as a collection of individual words, and we use a training set, and because Pang et al. Carefully put this corpus together with half positive and half negative ones, we can easily observe how much over that random baseline we would be. Bag of words with the kind of machine learning that Pang et al. Used, which is support vector machines as the best, and I think bigrams as one of the best, gives 80%. And when you use doc2vec, as you will, it will rise even above that. So here are some sentiment words which come from a paper about exclamations in movie reviews. So thanks shows a so-called J shape. What you see here are the log odds of positive and negative reviews. So the word thanks occurs medium often in a negative context, then very rarely in the neutral reviews, and often in the positive ones. So so what I'm going to ask you is what these shapes mean. Never has the opposite shape. So this is called a reverse J shape, whereby we also have a dip in the middle, but the dip is much larger on the negative side. Seems to occur more highly correlated with the negative sentiment reviews. Quite has this shape. Actually, funnily enough, not quite has exactly the same shape. So you can see that's lukewarm, right? It occurs a lot in the medium ones, and not so often. And ever is something that is a U shape. So what that tells us is ever occurs with extreme reviews, people who like it a lot and they don't like it a lot, but it can appear equally much with the negative as with the positive one. Who would ever go to see such a movie? Or let me think of a positive one.
Best one I ever saw.
Yeah, ever saw, yeah. Here are sources of errors for Bag of Words. Ridley Scott has never directed a bad film. We only have negative words in there. The meaning is he always makes good films. And then there's something called overfitting the training data. This has to do with timeliness. Like, many people think that Kingdom of Heaven was his worst movie. So up to then, see, this is actually something that is very annoying about sentiment detection. We want the sentiment detector not to learn which people are good directors and which people are good actors, because these things have nothing to do with sentiment, right? However, this is an effect that with this methodology, that we can't separate from learning from the real words. And with changing times, if you change to a different time frame, we can particularly easily see something is overfitting. There's also things like contrasts in the discourse. People write these reviews to be entertaining, and they want to surprise you. They say something like, this film should be brilliant. It's all the hallmarks of being brilliant. And you get lots of positive adjectives. And you can destroy that with just a little sentence that doesn't even have anything negative in it. Just it can't hold up. Just a negation in there, right? This is another contrast. This is someone who actually didn't like American Werewolf. And they talk about Judy Delpy and how great she is. And this is kind of pointing out that one aspect of the movie, namely this actress, is so classy and so wonderful that it doesn't fit the overall badness of the movie. And almost all of what is written here is a praise, and actually very emotive praise, very strong praise. It even ends. Sometimes people say, let's look at the ends and the beginnings. But, okay, here you see the failed. That wouldn't be too bad. But it ends on a positive note. Delpy, who was kind of, wasted on this movie, was radiant, charismatic, effective. In order to do it properly, and to actually learn something about the meaning that's contained in the text, you should do all the things that we teach you about in this course. You should do something about morphology, about syntax. You might puzzle together the semantics of who is talking about what, who is doing what to what, and so on. Lexical semantics, in the sentiment classification task, lexical semantics, of course, is extremely important. And there are even interesting effects that some words that are negative in a different context might be great in this context. So, for example, the adjective unpredictable is very good in a movie, but it's not so good in a car, for example, or in many other things. So that's also something that people have looked at. How does the domain, and again, if we had perfect world knowledge, we would know that. We would know why unpredictable is bad for a car and good for a movie. But here we could learn it from data, right? If you think in terms of discourse structure, you can anticipate effects such as people try to trick us or people try to surprise us with their review by looking for switches or looking for comparisons or looking for things like that. The problem is AI complete. AI complete is kind of a wishy-washy term that means if that problem were solved, we would at the same time have solved strong AI. That is, we would have reached full human intelligence in computers. That's what AI complete means. And people are generally saying solving language is the ultimate goal, the ultimate thing. Okay, I'm almost out of time. Question answering will be interesting to you because you will be answering those understanding questions. And of course, the trick is that the question is not usually in the same words as in text. France has been the French capital for many centuries. And unless we have here something like, but recently it was moved to Nancy, that means it still is the capital. It's a little bit of inference that is happening there. Machine translation, I have a joke in there. Are there any Welsh speakers in the room? Okay. This was found in a parking lot in Wales where the law requires that every English signage is translated into Welsh. And a concerned reader called radio station and it was taken down very quickly because the translation of the Welsh is the following. I am not in the office at the moment. Please send any work to be translated, which actually means that the civil servant that put this up on a board did not speak Welsh, had sent a translation request to a translator, had received this back and had put it up there. It's just a little joke. It was up for a few days. Dialogue systems. I'm seriously out of time. May I recommend something to you? These are lists, Lunar and Chuldu, of the first wave of AI and kind of impressive systems that talk about limited domains. And for those of you who have seen Google Assistant, the announcement of Google Assistant, they will have seen Google Assistant free calling a hair studio. And for those of you who haven't seen it, go on the web and have a look at it. It's very, very impressive. There's some tricks employed, of course, and it's a very limited domain. And it's trained on hundreds, tens of thousands of dialogues, I would guess. But nevertheless, dialogue systems have come a long way, right? There's lots of subtasks, but I kind of talked through them already. And I'll put these slides up on the web. General comments are NLP is kind of, we cannot expect to do hundreds. And there's a big difference between limited domains, which can be done quite well at the moment, and the big task of doing general understanding. Okay. Thank you. Thanks.